It's like it's pop beads that are interchangeable. It is almost as if somebody designed it that way so they could just mix and match the parts and make anything they wanted. Isn't it? Something to think about. Okay, but the problem with it from an engineering standpoint is this. You're not cutting with a blade. These are not precise cuts. The blade would have to be a few molecules thick. You're cutting with chemicals. Chemicals. Now, the chemicals can cut pretty accurately, but mistakes are going to happen. Something's going to ooze out where it doesn't belong. Something's going to splash over it where it doesn't belong. Mistakes are going to happen. Inevitable. We know that. We make mistakes all the time. Another problem with genetic engineering is you don't know what you're going to get when you do this. You can't predict. You have to decide what you're going to do. You have to do it. You have to let it express, which is live, and see what you get, and then use that to determine what you do the next time. And of course, the great fear in genetic engineering is somebody's going to make a mistake and create the Andromeda strain that's going to kill us all. A legitimate concern. Although everybody's very careful, and I'm not too worried about it. But mistakes do happen because all of this is so incredibly microscopic. It's out of the nucleus of your cells. Imagine how microscopic it is. But don't try to figure it out. I can't even figure it out. It's really complex. But they do it. Okay, understand that. Now, with that in mind, let's look at some of the proofs that I say indicate very clearly that we are, in fact, what the Sumerians say, a genetically engineered species by the Anunnaki. Next slide. Okay, here we go. The cerebral cortex is the deeply convoluted surface region of a brain that is most strongly linked to intelligence, lower right. It's the stained part out here. If you peel that off of the brain of a rat, it will cover a postage stamp. Peel it off of a monkey, it'll cover a postcard. Peel it off a chimp, it'll cover a sheet of typing paper. Peel it off of us, and it'll cover 4 sheets of typing paper. Now, you can see this is a transition. This is clearly a transformation. Now, there's some weird things about it. These guys are using all they've got. All they've got. We're using 1/2 of one page in a very different way than they are using what they have. 1/2 of one page. How do we know? We all know. We use about 10% of our brains. We know that from the studies done with idiot savants. You know that. And we know there are thousands of miles of neural network in our heads not being used. We don't know why. We don't know why. I'll tell you why. We shall make the atom who's strong but not too strong, smart but not too smart. They sealed it off genetically at the 10% mark or wherever it is. We don't know exactly where it is. But wherever it is, they sealed us off. You don't want your slave to be anywhere near as smart as you. You, in fact, want your slave to be so decidedly inferior to you that you never have to worry about treating it like a slave. So they engineered us to be really clever to ourselves, but for them, we were smart enough to talk, take instructions, act with a little bit of ingenuity and self-reliance. They could turn things over to us and kind of let us take over and do it. They gave us just enough to be wonderful in our own eyes, but be pond scum relative to them. It's what they did. So, it's pretty clear in as much as that, and now understand with the idiot savants, for those of you that don't know the proof about this, idiot savants get some beam of light in the damage to the good 10. They get some beam of light and it will strike somewhere in the other 90%. You all saw Dustin Hoffman in Rain Man, remember? Well, they get it in math, they get it in music, they get it in sculpture, art, whatever, wherever it strikes. Now, if there's just one, we could say, well, that's a freak of nature. But we've had lots of them, lots of them. So we know that all of this is out there. It's in our heads. We just can't access it. We just can't use it. But if it wasn't in our heads, it wouldn't be in their heads. So we know that it happened. They have no idea how. Well, I say that the Anunnaki did it deliberately, and that makes sense to me. Next slide. Okay, mitochondrial DNA, late 1980s, you might remember this. In humans, over 99.99% of a cell's DNA is packed into the cell nucleus, with a small amount occurring outside the nucleus in small structures called mitochondria. That's these babies right here. They're about 16,000 base pairs long. Now, when you have a mixing and a mating, the DNA in the nucleus mixes. But with the mitochondrial DNA, it does not. Sperm doesn't have mitochondrial, eggs do. And so females pass it down intact generation after generation. Well, when this was figured out in the 70s, Boy, the botanist and the geneticist said, great, great. Now we can go and find out if the split from the common ancestor was closer to 8 million years or closer to 5 million years. Remember that? We're going to now pin it down. It's going to be one or the other. We're going to figure it out. So they went out and they took the mitochondrial DNA of women all around the world, every race, every creed, every culture, every country, and they brought them back to the lab and they started working on them. And when the answers came in the late 1980s, it was not 8 million years ago. It wasn't 5 million years ago. It was way, way, way the heck down to 200 to 250,000 years ago, and that's all. We don't exist genetically beyond 200 to 250,000 years. And of course, needless to say, the anthropologist said, you guys are nuts. We've got these skulls showing, these bodies showing, these prehumans showing that we go back millions of years. What's the matter with you? And the geneticist said, we couldn't have been wrong that many times. Impossible. We'll do it again. And they have. They've done it. It always comes out the same. Outside 250,000 years ago. That's it. We're brand spanking new. Brand new on this planet. Now, there's still a lot of people, there's still a lot of people that will not accept that. A lot of people that will not accept that. But it is true, and it is becoming more and more acceptable, for as outrageous as it is. Now, not only do we know when we were created, we know where. Where? Because the oldest of us consistently kept coming in southern Africa. Next slide. And in fact, the cover of Newsweek in 1987 showed that if in fact there was an Adam and Eve, they were black. They would have to have been black. But of course they knew the flack they were going to catch, in the South at least, so they made the blacks look as white as they could. This guy looks almost as white as OJ, doesn't he? But the point is, in trying to have it both ways, they caught it coming and going, because you can imagine the letters to the editor after this issue. But the point is, it tells the truth. The oldest of us do come from southern Africa, and we definitely are 200 to 250,000 years old. And guess what else? That is just what the Sumerians say about us. That the Anunnaki created us around 200 to 250,000 years ago in southern Africa to dig their gold. What a coincidence. What a coincidence. Okay, next slide. Okay, what happens when a creature is born in the wild severely screwed up physically? What happens to it? Dies, right? Parents will kill it. It will not put that defect into the gene pool. You're looking at the great exception. You're looking at 28 of our most severe genetic defects, but we have 4,000 and counting. 4,000 and counting. Now, we're only 200, 250,000 years old. We shouldn't have one. We've got 4,000 and counting. How did it happen? Cutting and splicing process mistakes. Cutting and splicing, oops, made a mistake. Cutting, splicing, oops, made a mistake. They don't care. They're making a slave. They're not going to fix the mistakes. What do they care if it's 1 in 100 dies from the problems? If it's 1 in 10, they don't care. They're making a mistake. They're making a slave. But they know the numbers, like we have found out the hard way. If you let the population propagate naturally, those numbers go way down for each person. Right now, as we sit here, we average about 50 of the 4,000 each of us. And we have a mating with our mate. If we share any of those 50, then each of our offspring will have a 1 in 4 chance of expressing it. That's why you'll get mongoloids in the best of families, mongoloids in the lowest of families, and all around the world. And that's what genetic defects are. In the wild, you will get 2-headed calves and 6-legged goats. That's a sperm-egg misconnect. That's not something that you see steadily on and on. A little gem like spina bifida, which is not going to let you live to adulthood, nor is it going to let you reproduce if you do. What's that doing in a gene pool? It was all put there, folks. Put there. No question. Next slide. Okay, here we go, the chromosome match. It's kind of hard to see, comparison rather. Humans, chimpanzees, gorillas, and orangutans right here. And you see how similar they are. And as we know that between humans and chimpanzees, there's 99% similarity in the DNA and 98% with gorillas. And it's like, oh, well, then we're just kissing cousins. That's as close as you can be. We're almost the same thing. Well, not really. Because we're talking about a 3 billion base pair genome. 1%, that's 30 million base pairs. That's a couple thousand strands of DNA. if you know what you're doing, that's a lot of change. But also understand that all higher animals, and never say this, share 50% and up.